Yes friends, good morning. Welcome to our last video lecture to complete the exercise 3.5 as well as students the chapter. Now 13th sum, we are writing LHS is equal to b square minus c square upon a square into sine of 2a plus c square minus a square upon b square into sine of 2b, and last a square minus b square upon c square into sine of 2c. Again students, this is a symmetry type of sum, and symmetry type of sum students are always done by simplifying only one term. Now let us start the simplification of the first term, which is b square minus c square upon a square into sine of 2a. Now students, small abc indicates the application of sine rule, taking k square common, so I will get sine square b minus sine square c upon k square into sine square a, into 2 sine a cos a. Sorry, I should have written here capital A. K square and k square gets cancelled. Now sine square b minus sine square c is nothing but sine of b plus c into sine of b minus c, when sine a and sine a gets cancelled, upon sine into twice cos a. Now b plus c is pi minus a, and sine pi minus a is sine a, so this comes out to 2 sine of b minus c into cos a. Now students, I can convert a in terms of b and c. We can write this as twice sine b minus c cos of pi minus b plus c. Now cos pi minus theta is minus cos theta, so minus 2 sine b minus c into cos b plus c. This much very easily students we can write. Now 2cs, because plus term is for cos, so I am taking 2cs. You can take even 2s here. I am taking 2cs, which is s minus s. So sine of addition of two angles, so we will get 2b, and subtraction of, you can say, two angles, so we will get 2c. If I multiply by negative sign, this becomes sine 2c minus sine of 2b. This is what students we have in the final simplification. Now similarly, we can simplify the other two terms, c square minus a square upon b square into sine of 2b. Now check, if it is b minus c, here it is sine 2c minus sine 2b. So here first we will have sine 2a minus sine 2c, and last term a square minus b square upon c square into sine of 2c will be sine of 2b minus sine of 2a. Continuing with the LHS, sine 2c minus sine 2b plus sine 2a minus sine 2c plus sine 2b minus sine 2a. Sine 2a minus sine 2a, 2 LHS. Finally, students, LHS is equal to RHS. Hence, we have proved the sum. So, this is how, students, we complete the symmetry type of sum. Okay, students, now the last three problems are word problems which you have already done in height and distance, similar type of sums which are very well done with the help of figure. So, students, now the last three sums are word problems which we are doing, and concentrate on word problems because word problems are based on figures. The perfection in figure you have, correspondingly, students, your sum is done. I am reading the question. A tree stands vertically on a hillside which makes an angle of 15 degrees with the horizontal. Tree is standing on a hill. Word problem, answer 14, exercise 3.5. Say, students, this is the hill. I am showing one part of the hill to be like this. On hill, a tree is standing vertically. This is tree. Say A, B is tree, and let us suppose height of the tree is h meter. The hill makes an angle of 15 degrees with the horizontal, means ground level. This is ground, this is hill. It makes an angle of 15 degrees with the horizontal. From a point on the ground 35 meters down the hill from the base of the tree. This is base of the tree. So this distance is 35 meters. And from here we have, say, a point O, and say this is C. From a point on the ground 35 meters down the hill from the base of the tree, the angle of elevation of the top of the tree is 60 degrees. Angle of elevation of the top of the tree is 60. This total angle is 60 degrees. That is B1. This total angle is 60 degrees. So this much angle will be definitely 60 minus 50. How much? 45. This angle shows this much only. Entire is 60. Then we have to find the height of the tree. So indirectly h is required, and to find h, what are our basic steps? So if I describe the figure first, so this angle is 90 degrees, this angle will be fine, correspondingly this angle also we will find. So OC is equal to ground level, AB is equal to height of tree, and that is h meter. Distance OA is 35 meter. Now in triangle ACO, this is 15, this is 90, 105, so this will be 75, so this will be 105. Now this is 45 plus 105, 150, so this angle will be 30. Simple geometry. Then students, let us show this triangle AOB separate. For triangle AOB, let us show this triangle separately. So this is vertex A, this angle is 105. 45. This is vertex O and this is vertex B, having angle 30 degree. This O is having angle 45 degree. Okay. Distance OA is 35 meter. Distance AB is h meter. OB is not required. Okay. Now, students, I apply sine rule according to sine rule. Sine of 45 upon h is equal to sine of 30 upon 35. It is sine of A upon small a, so angle and opposite side. So h will be 35 into sine 45 divided by sine 30. Sine 45 is done by root 2, sine 30 is done by 2. So this becomes 35 root 2 meter, or you can multiply by 1.41, whatever is your answer. So word problems are 100% students based on your ability to draw the figure. Students, word problems are 100% based on your ability to draw the figure. That's all, students. This one only we have. So the final answer is 35 root 2 meter, which is the height of the tree. Okay, now students, we are doing word problem 15. Our next sum is, students, word problem 15. Here also one has to be very, very careful in drawing the figure. The sum reads as follows: two ships leave a port at the same time. One goes 24 km per hour in the direction of north, making an angle of 45 degrees with the east. Say answer number 15. Let us draw the four directions. Say at, you can say, time t is equal to 0. The ships are located at origin. Two ships leave a port at the same time, so O be the position of the port. O is equal to initial position, that is at the base of the port. Now, one goes 24 km per hour in the direction of north, making 45 degrees with the east. Now all of you know this is north, south, this is west, and this is east. So north making 45 degrees with the east means this angle is 45, so this will be also 45. And the other travels 32 km per hour in the direction of south, making 75 degrees with the east. This angle is 75. This also we have shown as 45. So this angle will be 15. Find the distance between the ships at the end of 3 hours. So this is B. And if I join, this will be the distance, say x kilometer, at the end of 3 hours. Now students, OA is equal to distance of ship in 3 hours. What is the velocity of ship going in the direction of OA? 24 km per hour. So it will be 24 3s are, which is 72 kilometers. OB is equal to distance of ship in 3 hours, which is going south at an angle of 75 degrees with east, and it is traveling at the rate of 32 km per hour. So in 3 hours it will travel a distance of 96 kilometers. And after t is equal to 3 hours, distance between ships is equal to AB is equal to x kilometer. Now, for triangle AOB, according to cosine rule, cos of angle AOB will be equal to OA square plus OB square minus AB square upon twice OA to OB. Cosine rule is always for the angle which we have considered, that the adjacent sides to binding its dash squares will be added and opposite side square will be subtracted. Now angle AOB is 60 degrees, so this becomes cos 60 degree. OA is 72 square plus 96 square minus x square upon 2 into 72 into 96. Simplifying, we get x square is equal to 7488. Now that much I will give for you. Cos 60 is half. X square is equal to 7488. Taking positive square, we get approximately 86.4 kilometer, which is our answer. So students, at the end of 3 hours, the separation between the two ships which have started from a port with initial position O will be 86.4 kilometers. Okay students, a similar type of sum is sum number 16. Students, a similar type of sum is our sum number 16. Let us do that. Now, students, pay attention. I am again reiterating, word problems will be always based on the figure. Two trees A and B are on the same side of a river. Now, answer 16. Say this is the river. It is first side, and say this is the second side. Say tree A and B are located here. On any side you can take, I have taken on this side. From a point C in the river, the distance of trees A and B is 250 meters and 300 meters. Somewhere here is a point C in the river. This distance and this distance are 250 meters and 300 meters. If the angle C is 45 degrees, find the distance between the trees. This angle ACB is 45 degrees. separation between the trees is said x meter. Now this is a very simple application, students, of cosine rule. Description of the figure is distance AC is equal to 250 meter. Distance BC is equal to 300 meter. Measure angle ACB is equal to 45, which is the point in the river. So here, according to cosine rule for triangle ACB, we have cos of angle ACB is equal to adjacent side binding angle, which is AC square plus BC square minus AB square upon 2AC into BC. Now cos of 45 degree is equal to 250 square plus 300 square minus x square upon 2 into 250 into 300. We can write distance between the trees. Distance between the trees is AB is equal to x meter. Now cos 45 is 1 by root 2. Simplifying with the help of simple letter, we get x is equal to 215.5 meters. That much I can leave for you to calculate, students, because you have to calculate using your simple calculator. So this completes our long chapter trigonometry. After a month, students, we are concluding this chapter. Month and more so. I told you we will complete by August end. We took exactly a week more because of some gap days or holidays in the month of August. You are requested to do these word problems thrice, and then, students, you have to, you can say, conclude the chapter. Thank you, students. We conclude the lecture. We complete exercise 3.5 and we complete our long chapter trigonometry. Thank you, students.